trying to finish this video. This is going to be take 57, it feels like. Every time I try, it keeps messing up. But here we go. Let's try to see if I can finish 33 through 40 for you. This asks us to solve an exponential equation. Notice the e. When you see an e, that probably means you're going to do natural log, because the natural log of e is 1. So here on the left, I'm going to write natural log, and I'm going to write the equation. And then on the right, I'm going to write natural log. So I'm going to take this exponent off and bring it to the front. So when I bring that to the front, it's negative 0.09t times the natural log of e equals the natural log of 0.18. Natural log of e is 1, so negative 0.09t equals natural log of 0.18. Solve for t, you're going to divide. When I divide, this cancels, and I get t is equal to, and then I can divide this on the calculator, which of course now that I restarted my computer, I don't have a calculator. Hang on. And here it is in the calculator. Natural log of 0.18, make sure that you close that parentheses. That can be a real problem if you don't. Divided by negative 0.09, and you get 19.053. So my answer for problem number 33 should be C. Problem 34, another solving problem. They have different bases. One is a 4 and one is an 8. Now you can log both sides if you'd like. That's one option. Or 4 and 8 can both be written as powers of 2. So how I would do this one is write 2 squared times x plus 2 equals 2 cubed times x. Because 4 is 2 squared and 8 is 2 cubed. So since the bases match up, I can just use the exponents. 2 times x plus 2 equals 3x. That'd be 2x plus 4 is equal to 3x. Subtract 2x from both sides, and you get x is equal to 4. So my answer is D. You can go back and plug it in, check it out, do 4 to the, if x is 4, this side would be 4 to the 6th, and this side would be 8 to the 4th, and they should be equivalent. Alright, so this logarithmic equation they want me to solve, the very first thing I need to do is combine it into a single log. Now since this is addition, a sum here, I can write it as a product. So x minus 7 times x minus 7 is equal to 1. So now I have a logarithmic equation. I'm going to rewrite it as an exponential. So it's going to be, to rewrite a logarithm as an exponent, you take the base, so it's 9 to the first equals x minus 7 times x minus 7. So 9 to the first is 9. This side becomes x squared minus 14x plus 49. Subtract 9 from both sides because you got to solve a quadratic. You want to set it equal to 0. And let's see, I think that will factor actually. You can do quadratic formula if you need to, but I need two numbers that multiply to give me 40 and add up to negative 14. It'd be negative 10 and negative 4. So for my solutions, I get x equals 10 and x equals 4. Now they won't both work. Obviously, if I'm looking here, the only thing that would work is the 10. And the reason why the 4 won't work, see, none of these, I don't have square root of 50 as an option. I don't have negative 10 as an option. I don't have negative square root of 50 as an option. The reason why 4 won't work is if I plugged it back in, that would make this a negative number if I plugged in 4, and we can't be taking the log of a negative number. This number right here would have to be positive. Number 36, I'm going to keep the left like it is. Natural log of 5x minus 4 equals, and on this side, I'm going to write it as a division problem. 8 over x minus 2. Now notice there's a natural log on both sides, so I'm going to drop that off. And I just have 5x minus 4 equals 8 over x minus 2. I am going to multiply both sides by x minus 2. So here, it would cancel over here and just give me 8. I'm going to have a quadratic equation. Alright, here on the left, if I do distributive property or FOIL, I'd get 5x squared minus 4x minus 10x plus 8. So that'd be 5x squared minus 14x. If I take 8 off both sides, that's equal to 0. So when I solve this, I get x times 5x minus 14 is equal to 0. So x equals 0, and x equals, if I solve this, I get 14/5. Will they both work? It's either they're both going to work or only 14/5 is going to work. So let's see what happens if I were to plug in 0. Natural log of 5 times 0 minus 4. natural log of 5 times 0 minus 4. That's on the left there. Oh, we got a problem. That one didn't work. So let's try it again with 14/5. Natural log of 5 times 14/5 minus 4. And that gives me 2.3, and it goes on. And on the right side, I'd have natural log of 8 minus natural log of 8 minus natural log of, it's supposed to be x minus 2. So that'd be 14/5 minus 2. And I get the exact same thing. So 14/5 works, and that's the only thing that works. The 0 did not work in this particular problem because it would make it a negative in here. All right, problem 37. Solve. In 1996, an outbreak of a disease infected 10 people in a large community. By 1997, the number of those infected had grown to 40. Find an exponential growth function that fits the data around the 3 decimal places. All right, hang on just a second. Okay, so our equation is going to be that our n of t, that's our amount we're looking for, will equal, our initial starting point is going to be 10. I should put this, we're ending at 40. So 40 will equal 10 times e to the kt. And t for this case is going to be after a year, because in 1996 we had 10 people. So that's where this initial 10 comes from. That's our initial starting. After 1 year, we had 40 people. So now what we've got to find is k. What is this exponential growth rate? So the first thing I'm going to do is I'm going to divide both sides by 10. 40 divided by 10 is 4. So I get 4 equals e to the k power, because k times 1 is k. I'm going to natural log both sides. So on this side, I get the natural log of 4 equals, I'm going to bring the k to the front, k times the natural log of e. And the natural log of e is 1. So this side's just k. And on the left side, the natural log of 4, I can come over here, the natural log of 4 is 1.386. So k is 1.386. My equation is going to be 10 times e to the 1.386t, where t is the number of years after 1996. Number 38, here they give me the function where t is the measured in years. How many books will the library have after 7 years? So I'm just going to retype this and plug in 7. So it's 8,000 times e to the 0.04 times 7. 0.04 times 7. Depending on your calculator, make sure all of that is in the exponent. And I get 10,585 books. So my answer would be A, 10,585 books. 39 is how long will it take a sample of a radioactive substance to decay to half its original amount if it decays according to this function. So half of its original amount, it's starting with 200. So half of its original amount would be 100. How long is it going to take it to get to 100 if we started with 200? Well, all I've got to do here is, so I'm trying to find t. Divide by 200 to start with. So I get 0.5 equals, because 100 divided by 200 is 0.5, e to the negative 0.133t. I'm going to natural log both sides. Natural log of 1/2 equals natural log of e. So natural log of 1/2 equals negative 0.133t times the natural log of e, which is 1. And I'm going to divide by negative 0.133. So natural log of 1/2 divided by negative 0.133. And I get, if I've done it correctly, about 5 years is how long it's going to take. 5.21 years is my answer, C. All right, the last question, they're just wanting you to plug in. This is a lake is stocked with 687 fish. They have a limiting value of 4,293, so they want to know, tells us what the population is after time t in months. So I'm just going to type this in. The key here is to make sure you type it in correctly. So in the numerator, I want 4,293. Let me clear this off. 4,293 divided by, and I'm going to put parentheses because there's a lot in this denominator. It's 1 plus 5.6 e to the um, negative 0.27, and t is 20. So negative 0.27 times 20. And if you want to do that, whoops, I'm going to delete that and move it back down here. All right, so it's 4,293 is our numerator, and all of this is in the denominator. There would be about 4,187 fish. So D would be my answer. That's your review. Good luck.